Let's go over this post-lab question from our flame test lab. It says to create energy diagrams for sodium and potassium. Let's start with that. Sodium and potassium are both group 1 metals with one valence electron. So we should expect both of these elements to have one valence electron in their final outermost s orbital. Here's an energy diagram with energy increasing as you go up the vertical axis. Let's start with sodium. Sodium has 11 total electrons. The first 2 electrons occupy the 1s orbital. Following alpha after 1s is 2s. Put 2 electrons in there. And after the 2s orbital, we have 3 p orbitals in the n equals 2 second energy level. Let's fill the first 3 using Hund's rule, and then pair them up. We have 10 electrons now. We need 1 more. After we fill the 2 p orbitals, we go into n equals 3, and we fill our final valence electron in the 3s orbital. Let's do the same for potassium. Potassium is 19 total electrons. Let's put the first 2 in the 1s orbital. And continuing with the alpha principle, we go to the 2s, then the 2p, then the 3s, then the 3p, and we skip the 3d for now and go to 4s. So our final electron is going to occupy the 4s orbital. Now let's take care of the second part of the question, where it's asking us to explain why the flame produced by each metal is a different color. So in our flame test lab, the station with sodium chloride produced a bright yellow flame, and the station with potassium chloride produced a lilac or faded purple flame. Now, our eyes are not spectroscopes, although you could have used yours. This question is basically asking why the different colors in the flame. And that boils down to you understanding that the photons produced, or the colors produced, is due to the electronic transitions. This electron is absorbing energy from the flame and is moving to a higher excited energy orbital. And when it returns back to its ground state, it's going to release a photon, or a specific wavelength of light. Now, you don't have to know the specific electron transition that produces a specific line in an emission spectrum. You just have to explain that the electrons that are transitioning in a sodium atom is different in energy than the electrons transitioning in a potassium atom. And that should be clear with your energy diagram side by side. The differences in energies, the delta E, between any 2 orbitals in these atoms are different from each other. And part of the reason for that is the nuclear charge is different between sodium and potassium. Sodium has 11 protons in the nucleus, and potassium has 19 positive charges in the nucleus. So they both have different attractions between the nuclear charge and the negative electrons, which make the occupied energies of the electrons of each element different from one another. Now, there are other factors such as orbital penetration and shielding, which we haven't gotten to yet. But for now, you can say the flame colors between these 2 elements are different because their electrons have different energy level spacings. So when the electrons fall back to lower levels, they emit photons with different wavelengths.